Hello everyone. In this video, we are going to discuss my internal one questions from question number 1 to 8, part A and B of my question paper. Question number 1 is give three more commonly used statistical measures for characterizing dispersion in student feedback data and discuss how these measures can be computed efficiently in large student database. So, Measures are range, variance, standard deviation. All these are measures. What is range? Range is the difference between the maximum and minimum values in the dataset. Application of ranges show the spread of student feedback. Variance is the average of the squared difference from the mean. Application of variances measures how much feedback rating deviate from the average effectiveness. Standard deviation square root of variance. So application of standard deviation is helped to understand the consistency of student rating. Smaller standard deviation means more agreement. After it, efficient application in large datasets. Use summary statistics and group computation. Example using SQL and group by or Panda group by. Apply vectorized operations or streaming algorithms to avoid recalculating the entire dataset each time. Store aggregated matrices for each course or faculty to analyze trend efficiently. Suppose that the student feedback, question number 2 is suppose that the student feedback on faculty mentoring effectiveness is given in sorted order 13, 15, 16, 19. These are all the order. So number of observation n is equals to 25. We have to find mean. So the formula of mean is sum of all observation divided by n. So mean is equals to 28.8. For median, value at n plus 1 divided by 2's position. So there is 13. So median is equals to 13. After it, mode has a formula. Mode is the value that is frequent. So the most frequent value is equals to mode. 25 and 35 is the mode here. What is the mid range of the data? Mid range is equals to minimum value divided by 2 plus maximum value. So this is 83 by 2, which is 41.5. After it, uh, estimate the first quartile and the third quartile. So we can also estimate it using these formulas. After it, give the 5 number summary of the rating. 5 number summary is minimum 13, question 1, 20, median 25, with there 35.5 and maximum 70. After it, draw a box plot of the data. Box plot is left whisker 13 to 20. Box from question 1 20 to question 3 35.5. Median at 50 at 25. After it, right whisker 35.5 to 70, and distribution is right skewed due to high outlier 70. Now we have to write difference between quantile plot and QQ plot. So quantile plot is the data values against their quantiles, and QQ plot compare quantiles of two data set. Quantile plot showed spread and skewness of one data set, while QQ plot test if data follows a theoretical distribution. Then quantile plot used to visualize quartiles, medians and range, while QQ plot used to check normality or compare distributions. After it, question number 3 is suppose student lab infrastructure satisfaction score are grouped into intervals with the following distribution. This is a distribution we have to find median here. So we can write formula of median and can find this. After it, question number 4 is in the Department of Lifelong Learning, a feedback survey collected both student age and their assessment of learning productivity for 18 students. So this is the data, and we have to write formula. We have to use formula of mean, median, and standard deviation, and we have to put values into it. Then we can find mean is equals to 28.7833. You can see our calculation here on the screen. After it, median 30.7, standard deviation is 9.254. After it, question number 5 is briefly outline how to compute dissimilarity between a student feedback profile described by. So nominal attributes and asymmetric binary attributes. You can see here is the formula of dij, distance for nominal. So we can use this formula and calculate This after it asymmetric binary attributes. This we can also find by this calculation. You can see here after it numerical attributes. We can use this all these methods for it. After it term frequency vector. So this is also common dissimilarity measures. Cos theta is equals to AB divided by this. So all these you can see on screen. After it, question number 6 is suppose two student faculty interaction profile are represented as tuples as given in question. You can see on screen. After we have to find out Eulerian distance and all this four things that is showing on a screen. So we can calculate it using this formulas as you can see the calculation here. After it, question number 7. The median score is often a key holistic indicator of faculty or infrastructure performance when dealing with massive student feedback dataset. Propose method for median approximation analyze their complexity and suggest heuristics to balance accuracy. Exact selection, you can see idea use the linear time selection algorithm to find the kth order statistic exactly. So the time is big O of n and the space complexity is big O of 1. So this is about exact selection. After it, two pass approach. So in this first pass to build value histogram or locate bin in containing median. So the time complexity here is big O of n and space complexity is big O of b. After it, streaming quantile. Here you can see also the idea is maintain a compact summary with guaranteed approximation to any quantile. Time complexity is order of log 1 by e and space complexity is big O of 1 by e log sigma n. Fourth is T digest for real valued data skew handling. Idea is cluster values into centroids preserving tail accuracy. You can see time complexity and here. After it, heuristics to balance accuracy vs efficiency. So this is all about it. Choose algorithm by constraints. If strict accuracy needed and dataset fits, random access possible. If streaming or single pass required, then T digest. If very tight memory, then approximate median acceptable if distributed, and histogram binding with refinite or mergeable summaries. Question number 8 is consider student faculty similarity analysis. You can see here uh, we have to normalize it and rank listing also we have to uh, find out here. So this is step 1 list vectors. So you can see in this table we list all vectors and after it in step 2 compute distances or dissimilarities. So we have computed in the table dissimilarities and distances. Okay. After it, step 3 is ranking. So we rank on the basis of all this four S1, then after it S4, then S3, and then S5, then S2. So this is all about step 3 ranking. After it, step 4 normalized. So we can normalize it. Then after it, normalized ranking will be S1, S3, S4, S2, and then S5.